Welcome to ScienceCover.com. This session is on nuclear fusion. The aims of the session are to find out what nuclear fusion is, to study the reactions that go on within the Sun, and to find out if this is a process that we can use to produce energy in the future. Pause the video now and attempt the Do Now task. Let's check our answers. Number 1. What is a nuclear fission process? So this is the process of releasing energy by splitting an atom from a large unstable atom into smaller, more stable atoms. Number 2. What is meant by a chain reaction? This is when the neutrons released from the fission process trigger the start of the next fission process. This releases a large amount of energy in a short space of time. How can nuclear fission be used to create electricity? Uranium fuel cells are used to produce fission reactions. The heat from these reactions boil water into steam, and then the steam will spin a turbine which spins a generator. Number 4. What is the process of a control rod? The control rod absorbs neutrons to slow the fission reaction. Number 5. What is a meltdown? This is when the core of the reactor produces too much heat in a short space of time, and then the uranium will melt and become molten uranium. What happened at Chernobyl in 1986? Well, firstly, the reactor exploded, and this threw large amounts of radiation into the atmosphere. The control rods could not be reinserted into the reactor, and this meant that the reactor went into a meltdown. Let's begin this session by looking at what we mean by nuclear fusion. What is the most stable element in the universe? We can find out by investigating elements' binding energy. The binding energy is the amount of energy required to remove one particle from the nucleus of an atom. So this could be removing a proton or removing a neutron from the nucleus of an atom. This graph shows the average binding energy per nucleon. That means it's showing us how much energy is required to remove a particle from the nucleus. And you can see for hydrogen and helium, these elements are very low down, which means that it requires very little energy to remove a particle from the nucleus. However, iron, Fe, is the highest point on this graph, and this shows that this element requires the most energy to remove a particle from the nucleus. And that means that iron is the most stable element in the universe. Anything to the right of iron is lower than it on the graph, and that means that it is less stable than iron. So uranium is marked on the graph, and we can see that it is lower down, so it is less stable than iron. This means if we split uranium into smaller atoms, it becomes more stable, and this releases energy. So this was the fission process that we were looking at nuclear power stations, the uranium breaking up into smaller elements like barium and krypton, releasing energy and releasing neutrons. But also, anything to the left-hand side of iron is also less stable than it. So in this case, if we combine these elements together, if we make these elements bigger, then they become more stable. So this is the process of nuclear fusion. It's where we stick atoms together, and this makes them more stable, so that's going to release energy. So nuclear fusion is when small atoms are forced together at high speed, and they create larger atoms, and as they are more stable, they release energy. Now this is the process going on inside the sun, and this is the process that the sun uses to create its energy. Pause the video now and complete task 1. Let's check our answers. What is the binding energy? This is the energy required to remove a particle from the nucleus of an atom. Complete the labels on the diagram. On the left-hand side, we have nuclear fusion. Iron is the most stable element. And on the right-hand side, nuclear fission is releasing energy. How can we produce energy from atoms that are larger than iron? We need to break these atoms into smaller, more stable atoms. How can we produce energy from elements that are smaller than iron? We need to fuse these atoms together to create large, more stable atoms. Now let's investigate the process that goes on inside the sun. The sun is made of different layers. However, it is only the core of the sun at the very centre where nuclear fusion processes happen. This is because it is the only part of the sun where the particles are travelling with enough energy and speed to fuse together and create new elements. The nuclear fusion process that goes on within the sun changes hydrogen into helium. However, the sun contains several different types of hydrogen. We have regular hydrogen with one proton and no neutrons, a type of hydrogen known as deuterium, which has one proton and one neutron, and a type of hydrogen called tritium, which has one proton and two neutrons. Now these are called isotopes of hydrogen. They've got the same number of protons but different number of neutrons. Now there are several different processes that go on inside the sun, converting hydrogen into helium. In this particular process, we can see deuterium, one proton and one neutron, and tritium, one proton and two neutrons, combining together. This will create helium with two protons and two neutrons, and a free neutron. Some of the processes can be far more complex. This diagram shows one example. But in general, they are still just turning hydrogen into helium. Pause the video now and complete task 2. Let's check our answers to task 2. What are the names of the three types of hydrogen isotope found inside the sun? We have hydrogen, deuterium, and tritium. Show how these isotopes can combine to form a helium atom. Well, if we take a deuterium and a tritium and react them together, we can create helium and a neutron. Why does this process only happen at the core of the sun? It's the only part of the sun that has enough heat and pressure. The temperature is at its highest, which means that the particles are moving fastest, and the particle collisions have the most energy. The final objective for this session is to look how nuclear fusion may be used in the future to produce energy. Nuclear power stations currently use radioactive uranium to produce their energy using the fission process. However, nuclear fusion can produce much more energy with no radioactive waste, with no CO2 emissions, SO2 emissions, or NO2 emissions, and no methane gas. The only byproduct from this reaction would be helium gas. Let us compare nuclear fission and nuclear fusion reactions. We'll look at what is good and what is bad about each. Let us compare the nuclear fission and nuclear fusion reactions. We will look at what is good and what is bad about each. Nuclear fusion uses a clean fuel, hydrogen. The only byproduct is helium. It doesn't produce any radiation, no carbon dioxide is emitted, and vast amount of energy can be created. The downside to nuclear fusion, however, is that it's very difficult to create and maintain conditions at high pressures and temperatures. As of yet, it's not actually been achieved. Nuclear fission, we know, creates large amounts of energy from very little uranium power source. It also does not produce any carbon dioxide emissions. But the downside of nuclear fission in power stations is that it produces radioactive waste that will remain radioactive for thousands of years. We also have the potential of a nuclear meltdown. Many countries have already invested large sums of money trying to create the world's first fusion reactors, but it remains difficult to achieve, as it requires simulating the heat and pressure at the core of the Sun here on Earth. As of yet, this has not successfully been achieved. Pause the video now and complete task 3. Let's check our answers to task 3. What waste gas is produced during nuclear fusion? That's helium. Complete the table to show some advantages and disadvantages for fusion and fission. So we know that fusion is a clean fuel. It only produces helium as a byproduct. It gives off no radiation. There's no carbon dioxide emitted, or nitrogen dioxide, sulfur dioxide, or methane gas. There's vast amounts of energy that could be created. Its disadvantage is that it's difficult to create and maintain conditions at high temperatures and pressures. The advantage of a fission reaction is that it produces large amounts of energy from a very little source. It also produces no carbon dioxide emissions. The disadvantage for a fission reaction is that it produces radioactive waste, which will remain radioactive for thousands of years. We also have the potential of a meltdown. Question 3. What issues have made it difficult to produce energy using nuclear fusion? So creating and maintaining conditions similar to the core of the Sun, and producing enough heat to trigger the initial nuclear fusion of a hydrogen atom.